Hello students. Today we are going to study about chapter 13 Fun with Magnets part 2. So in the previous video we have studied about what is magnet, what are the types of magnets and also about the properties of magnet in the first two parts. Now let us come to the next thing which is about fun with magnets. So the first question arises that what is magnetic field? This we have already discussed, but let us have a quick review. That what is magnetic field? The area around magnet in which the effect of magnet can be experienced. This is known as magnetic field. So if you remember that in a small video we have seen that there was a surrounding, there was a ground, an area under that only the magnet can work. If we cross that boundary, the magnet will not be able to work. For example, when you uh, play hide and seek, you tell your friends that this is the boundary. If you go out of this boundary, then you will be out of the game. So the same thing happens with magnetic field. So magnetic field is basically the boundary, the area. If something is out of that boundary, then the magnet will not be able to attract any material in that. So that is known as magnetic field. So to make it understand more, let us let us see one video.
You've seen a magnet with this shape before. It's called a bar magnet. It looks like a chocolate bar. What happens if we bring it near an iron nail? We know that as we bring it closer to the nail, at some point the nail moves towards the magnet and sticks to it. Moreover, it remains there until we manually separate it from the magnet. So why does an iron nail stick to the magnet? This is because of the force of attraction that binds the magnet and the nail together. This force is applied by the magnet on the nail and hence it's called a magnetic force. Here is one interesting question that I want you to answer. Is magnetic force a contact force? In other words, is the contact between a magnet and the nail necessary for the magnet to attract the nail? Let's look at the animation in slow motion. We are moving the magnet towards the nail. And at this point, the nail also begins to move towards the magnet. It means the force came into action even when there was no contact between the magnet and the nail. Hence, we can say that a magnetic force is not a contact force. Contact is not necessary for the magnetic force to work on the nail. To understand this better, we bring this magnet close to the nail and move it slightly up in the air. You will find a slight movement in the iron nail as well. This means that the iron nail is under the influence of a magnetic force even though it's not in contact with the magnet. It again proves that a magnetic force is not a contact force. So we can say that it's a non-contact force. The force exists even though the magnet is not in contact with the iron.
So we have concluded that magnetic force is basically a non-contact force. Non-contact force means it do not need a touch. Okay, it do not need any touch, any contact, then also it will work. So you must have read in the previous classes that magnetic force is a type of non-contact force.
Iron. But what does this non-contact nature of the magnetic force tell us? It tells us that there is an invisible field produced by the magnet in the space around it. And if you bring any ferromagnetic material in this field, then it experiences that force of attraction. We cannot see this field, but it exists. This field is produced by a magnet and hence it's called a magnetic field. Now I'll ask you an interesting question. Do you think the strength of this field is even throughout the area around the magnet? Let me explain this to you with a relatable example. Assume that there is a working Wi-Fi router present at some location. It gives off signals in all the directions in some range. Now, in order to connect a mobile phone to the internet, we need to bring it in this range only. This signal will be stronger nearer the router. The closer you bring your cell phone to the router, the stronger the signal will be. One can think of magnets in the same way. A magnet has a magnetic field around it. The strength of this field is greater closer to the magnet and decreases as we go further away from it. As you bring any ferromagnetic object in this field, it experiences a magnetic force. The closer we bring that object to the magnet, the greater the force it will experience until at some point where the force will be large enough to make the object leap towards the magnet.
Yes, so we have studied that the magnetic force is stronger if we are closer to it. Once we are getting away from that area, then the magnetic field is basically becoming weaker. Okay, so let us continue with the concept. Yes, so we have studied about this. Now let us come to the next concept, which is magnetic materials. So what is magnetic material? Magnetic material is basically those materials which get attracted towards the magnet. Magnet की तरफ खींचे चले जाते हैं. Those materials are known as magnetic materials. For example, iron, nickel, cobalt. Then we have non-magnetic materials. It's just opposite of magnetic material. These materials are these materials do not get attracted towards the magnet. ये magnet की तरफ खींचते नहीं हैं. They do not get attracted towards the magnet. For example, gold, copper, aluminium, paper, and rubber. You can also give examples like other examples like wood, plastic. These are also not non-magnetic. They are also non-magnetic materials. Now, we have also studied about the property of magnets, that magnet help us to know the direction. So this property we use in magnetic compass. In magnetic compass, which is used to find directions, it is having a metal case with a glass cover. Okay, and there is a magnetic needle always inside it, and that needle is basically a small magnet. Okay, it is basically a small magnet, and it rotates inside that case. And because it is a freely suspended, it is free to move. That's why it will always point towards north south direction, right? So that's why it is the magnetic needle is placed in it. Now we are going to make our own magnet. It is very easy to make your own magnet. You need to take any iron piece. It's written rectangular piece of iron. You can take any piece of iron, right? And then you need to use the bar magnet. You only need two things in this: one piece of iron and one bar magnet. So let us see a small video related to this, so that we can understand that how we can make magnet. Just a second.
Now, this is an iron nail, which we have often seen. It is actually attracting this particular pin, which is sticking
See, you can see that this is an iron nail, and it is here working like a magnet. So here we are going to make our own magnet with the help of these things.
to it. But how does this happen? It happened because we created a temporary magnet out of this nail. I will show you how this is done. We will use a single touch method. We need a bar magnet, iron nails, and pins. Let's begin. We will take this iron nail and hold it up. Since we are using single touch method, we just need one magnet. We will run this magnet along this nail from one end to another in one smooth motion as many times as we can. You need to take care that motion is uniform, has similar speed, and is not too slow or too fast. After you think you've dubbed a number of times, bring the nail near the pins that we have here. What do you see? The iron nail is attracting the pins just like a magnet. So the iron nail has got magnetized. Since the nail will lose its magnetic property after some time, it is considered as temporary magnetization. In the single touch method, a single magnet is moved along the surface of the nail in a single direction.
Make it a point that you need to use it in a single direction. If you are using in a back direction, then rub it in a back direction only. And if you are using it in a front direction, then you need to rub it in the front direction only, right? So if you are going clockwise, go it clockwise. If you are going anti-clockwise, then rub it anti-clockwise only. Okay, because if you change the direction of the rubbing, then it will not be able to magnetize itself. Okay, and it is a temporary magnet, so it will lose its magnetic power within 2 3 minutes. So it is a temporary magnet which we are making.
end to end many times. Now make as many magnets as you can with this method.
So you can make as many magnets as you can with this method, right? It's so easy and funny, right? Okay, so let us continue. Next, we are going to study about a few cautious things which we should take care. We should have the precautions while using magnets. That magnets actually lose its power when they are heated, hammered, or dropped from height. Magnet can lose its magnetic power if we are heating it, if we are hammering it, right, or we are dropping it from a height. So we should store magnet very properly so that its magnetic power do not get loose enough. Okay, and to do that, bar magnet should be kept in pair with their opposite poles on the same side. ठीक है, opposite poles को same side रखना चाहिए whenever you are keeping a bar magnet. They should be separated by piece of wood, and two pieces of soft iron should be placed at the two ends. It should be kept in between one small separator, which can be a wood or a plastic, and then you keep your two magnets together. You can keep like this. Don't keep it um, loosely. Okay, आप ऐसे ही नहीं छोड़ सकते उसे. You need to keep something in between so that its magnetic power do not get lost. Then for a horseshoe magnet, a piece of soft iron should be kept across the poles. Poles के पास रहना चाहिए एक छोटा सा soft iron. Magnet should be kept away from the radio, television system, music system, computers, mobile phones, cassettes, compact disc, that is CD. You should keep these things away from magnet so that can magnet cannot lose its power. Now let us have this definition which is very important, that is known as demagnetization. Demagnetization is basically the loss of magnetic power of a magnet. This is known as demagnetization. The magnet loses its power and it loses its power of attraction. So that is that property of a magnet, or that condition of a magnet is known as demagnetization, right? So we can use the magnet, we actually use the magnet in our daily life. So these magnets are used in ovens, these magnets are used in subways, these are also used in refrigerator, televisions, TV, microwaves, and there are a lot of things in which magnets are used, right? Magnets are even placed in the stomach of cows to catch metals. ठीक है, मेटल्स को कैच करने के लिए ये एक्चुअली थोड़ा सा लॉन्ग प्रोसेस है, और ये यूजुअली डॉक्टर्स यूज करते हैं so that they can catch the metals and they can keep it out of the body of the cows. Okay, so these methods are used in our daily life. We use magnets everywhere. Thank you very much for watching this, and I hope you have understood the chapter.